In the last video, we looked at physical properties, and in this video, the last video for the unit, we are going to be looking at chemical properties and chemical changes. So when we observe chemical properties are a little bit harder to observe. Really, a chemical property is just the ability to produce a change. So the actual chemical property, the item is not changing. But for example, let's say that you say something is flammable. Okay, when you say something's flammable, we know that that means that it can burn. Okay, and it burns in the presence of oxygen. But when you say it's flammable, it's not at the present time burning, but that means it has the ability to burn. And as it's burning, it will be going through a chemical change, which we'll mention here in a second. But chemical changes mean that you are altering what material you have. It is changing to something new. Wood is flammable, gasoline, even clothing is flammable. So flammability is an example of a chemical property. How reactive something is also a chemical property. So when you say that iron is reactive, because iron can rust in the presence of oxygen, then that is also a chemical property when you're stating how it can combine with other chemicals to form new substances. Oxygen, again, highly reactive because it can form rust, and we also have nitrogen, for example. It doesn't react with a lot of other items. It has pretty low reactivity, and so that would also be a chemical property, knowing that it doesn't really react as easily as something else. Now, you need to be able to recognize chemical changes, and a chemical change is when your piece of matter is going to react and form something new. So what you have at the end of the change is chemically different than what you had at the beginning. Whenever you bake something, baking, cooking, in general are always chemical. The only type of baking that isn't is just when you're boiling water, because boiling is just a phase change. Water in the liquid form going to water in the gas form of steam. But any other type of baking, when you're cooking something in the oven, that's always going to be a chemical change. When leaves change color in the fall, that's also chemical. Obviously, when you digest your food, it's different. You're taking the nutrients out of it, therefore what you started with is not what you're ending with, and that's going to be a chemical change. Now, there are a few pieces of evidence that you can use to help you to decide if something's a chemical or a physical change, and one of them will be a change in color. Now, change in color can be tricky. It is not 100% always a chemical change, but it can be. So this one you have to be a little leery about. You have to always ask yourself, is what I have now different than what I had at the beginning? When a match burns, the color changes. You know, the tip of the match is usually a certain color, maybe red, for example. And afterwards, it's kind of that burnt. So that would be a color change, and that's chemical. Copper roof. Okay, this is copper. We know that color, but it is very reactive, and so over time it turns this bluish color. It's called patina. So that's a chemical change because the copper is actually reacting, and this top layer isn't copper anymore. When something produces a gas, now we're not talking about steam, when water changes from liquid to gas. We're talking about when two things are put together, like vinegar and baking soda. Maybe you did this when you were younger and you made like a volcano. So all you do is put baking, you can do this at home too, just do it over your sink, but put baking soda in a glass and just add vinegar, like you would use for Easter eggs or something, and you'll have this really cool foaming stuff coming out the top, and you'll hear it, the little gas bubbles, just like when you open up a can of pop and you hear that fizzing. You have that gas that's going out into the atmosphere. So that would be an example of a chemical change. And then this is a vocabulary word you need to be familiar with. It's called a precipitate. We're not talking about outside precipitation, snow and rain. We're talking about a precipitate. And a precipitate is a solid that forms when you add two liquid mixtures together. So this is really cool. You'll take two liquid mixtures which have chemicals dissolved in them, but they're kind of see-through. We'll do an example of this in class so that you'll get to see what a precipitate looks like. But when you put the liquids together, you will see these solid particles like you see here that obviously form. You'll be able to see them. It's very obvious. And that the solid particles are called a precipitate. Whenever you add acid, normally it's like a vinegar or something like that, acetic acid, when you add that to milk to make cottage cheese, that's another type of precipitate because you have solid particles from two individual liquids. Now, in order to truly know if something's a chemical or a physical change, you have to ask yourself, does the composition of the matter change? So at the chemical level, is the matter that I started with the same matter that I have at the end, or have I chemically altered it into something new? A chemical change is going to alter it into something new. A physical change will not. So, for example, again, when you take that tomato and you cut it in half, what you started with is still chemically what you have at the end, it's just in a smaller size. Chemical changes, what you start with and what you end with, are two different substances. And if you have questions, please definitely ask. And that is the end of this unit. We'll be getting ready for a test here soon.